Today's lesson is on volume. Specifically, we're going to find the volumes of cones, cylinders, and spheres using the appropriate formula. Then we're going to learn how to rearrange those volume formulas to solve for an unknown measurement. All right, so the key terms involved in this lesson are the word volume, which is the space inside a three-dimensional object, what a three-dimensional shape is. We're going to discuss what a cylinder is, how to find the volume of a cylinder, what a cone is, how to find the volume of a cone, and the same thing with a sphere and find the volume of a sphere. All right, so these on the right-hand side here are the formulas for each of those shapes. All right, so this is the formula for the volume of a cylinder. Notice how it says that the V, which stands for volume, is equal to this big B, which stands for the base area, times the height. Whenever you're looking at these volume formulas and you see that large B, the capital B, right, that means that it is the area of the base. All right, so that's different than when you see a formula that has a little b, where they're just talking about a measurement of a base, like in a triangle. All right, so when we're doing with the volume of these objects, we need to find the area of the base, and then we apply the rest of the formula. All right, so let's take a look at the volume of a cylinder formula first and talk about how to find the volume of a cylinder. So here we can see that the volume of a cylinder is equal to the base area. Remember, that means base area right here, not the base area, times the height. And then we have that equaling to pi r squared times h. All right, so first thing we got to look at is this question here. How would you find that area of the base? And that's why this formula breaks down and simplifies to pi r squared times h. Because in this case, if we're looking at a cylinder, right, the base are the two shapes that are parallel and congruent. In this case, a circle. All right, so this down here is called a base of the cylinder, and we need to find its area. All right, well, the base of a cylinder is a circle. And if you recall, the area of a circle, right, the area of a circle is equal to pi r squared. All right, so that's why this b here in this formula has been replaced with pi r squared, because in a cylinder, the base area is a circle, and the formula for the area of a circle is pi r squared. So we find that area down here. So basically what we're doing is we're finding that area, and then we're sweeping up. We're multiplying that by the height of the cylinder. In this case, there's a more technical name for this type of cylinder. So when you're looking at something that looks like this, like a Coke can, where those bases are right parallel and above each other and congruent, we call it a right cylinder. There is a such thing as an oblique cylinder, where imagine if this side, this lid here was kind of pushed over to the side and it was slanted, right? Then we would call it an oblique cylinder. All right, so let's take a look at this figure here. Let's calculate the volume of this cylinder. All right, so let me get rid of some of my marks there. All right, so we can see that the radius of the circle is 2. The radius of that circle is the base, remember? And then the height of this is 6. So we're just going to use the formula and plug in the appropriate values. All right, so the formula, which is equal to the area of the base times the height, is equal to pi, which remember is not a variable. And unless otherwise instructed, if you just want to calculate an area to a few decimal places, you're going to use the approximation that pi is about 3.14. Right? So it's equal to pi times the radius. Okay, so they're talking about the radius of that circle. Okay, so it's 2 squared times the height. Okay, in this case, it's 6. All right, so we plugged in the variables into the appropriate place in the formula, and now we're just going to use a calculator to solve this. All right, so this is equal to pi. Remember, when you're working out these formulas, make sure you follow the order of operations, right? We have to square that radius first before we can do any multiplication. So the first step I do here is take 2 squared, 2 to the second power, which is 4. and then times 6. And then now I can go ahead and calculate this area if I wanted it to a decimal. 4 times 6 is 24, and we still have it being multiplied by pi. And so I could say that the volume of this cylinder was 24 pi cubic units. So I didn't have a label here, so I'm just going to say that they're cubic units. So remember, whenever we're dealing with a volume of something, the units are always cubed or cubic. Okay, so I could leave the answer like this, and this is what we call exact, left in terms of pi. If I want to go ahead and calculate the decimal equivalent, then I'm going to replace pi with, the approximation 3.14. So 24 times 3.14 happens to be 75.36. So the volume of this cylinder is about 75.36 cubic units. All right, let's do another example. So I want you to take a moment to pause the video and see if you can calculate the volume of this cylinder. All right, so now that we have the formula listed here and all the dimensions that we need are given in the diagram, we can just plug them into our formula. So this is what we call plug and chug in mathematics. Right? The volume is equal to the area of the base times the height. How do we find the area of a base? Well, the base here is a circle. So the area of a circle is pi times the radius squared times the height. Pi, fill in the volume number for the radius, which is 3, times the height. In this object, it's 8. Okay, so that is a 3 there. All right, so I continue simplifying. Remember to square first. So now we have pi times the 9 times 8. So if I left this answer exact in terms of pi, I would multiply these two numbers, 9 times 8, which is 72, and then it's still being multiplied by pi. So this would be the exact volume. And then if we want our decimal equivalent, I can use the approximation that pi is about equal to 3.14. And then we're going to multiply 72 times 3.14. And we get that the volume is about 226.08 cubic units. So if I had specified in this diagram that these dimensions were in, say, centimeters, like this, then I would have reported that the volume was 226.08 cubic centimeters, which we write this way, centimeters cubed, or you could even write out the word cubic centimeters. All right, so let's continue our discussion of cylinders here. We know the volume formula, we can see it there. Read this question. A cylinder has a volume of 105, and it should say 105 cubic units, whatever the units are, and it has a radius of 8. What is the height of the cylinder? So now this time, notice that they're not asking us for the volume of the cylinder, but they're asking us for the height of the cylinder. And they've given us the volume. Right? So make sure you read what's been given to you. But we can still use the same formula here because this same formula relates volume and height and radius of a cylinder. All right, so I'm going to go ahead and write our formula that volume is equal to pi times the radius squared times the height. I'm going to go about plugging in my unknowns, or the values, excuse me, that I do know and solve for an unknown. So in this case, we're told the volume here is 105. Right, so for the V, I plug in 105 equals pi times the radius squared times the height. Oh, but then it went ahead and told us what the radius was. We're told that that is 8. Okay, so now I know that 105 is equal to pi times the radius, which is 8, squared times the h. And then now notice that we've written an equation here that only has one unknown, in this case the height. So when we have an equation that only has one unknown, we can use our inverse operations to solve. All right, so I'm going to go ahead and simplify this left-hand side a little bit. So we get that 105 is equal to, remember we have to square first. So that would be 64. So it's like saying pi times 64 times the height. If you really wanted to right now, you could go ahead and continue to simplify this right-hand side if you wanted to get a decimal equivalent, right, and multiply the pi times the 64. Right, really here's what we have is 3 different quantities being multiplied. So if I want to undo that, right, we undo that with division. Let's go ahead though and simplify, continue to simplify on the right-hand side so we get our decimal equivalent. So I'm going to multiply the 64 times pi. Remember, we're letting pi represent as about equal to 3.14. All right, so 64 times 3.14 is 200.96. So now we have that 105 is equal to 200.96 times h. All right, so now we have a simple one-step equation. So some number times 200.96 equals 105. I want to isolate that variable. Oops, excuse me. I want to isolate that variable. So then to undo multiplying by 200.96, right, we divide both sides by 200.96. Right, so this is just solving an equation, isolating a variable. All right, and this cancels on the right-hand side. And then so now it's a calculator problem where I am dividing those two quantities. So I'm taking 105 and I'm dividing it by 200.96. And I get an approximation that the height here is about equal to, so whenever you see me write those squiggly little equal sign, that means about equal to. The height is about equal to 0.52. I'm going to round it to 2 decimal places. 0.52 units. So remember, volumes are cubic units. A length, like a height here, is just whatever those units were. In this case, it's not specified, so I might just write that it's 0.52 units, whatever those units are. Now let's move on to looking at the volume of a right cone. So again, it's called a right cone because we can draw a perpendicular from the vertex of this cone, that's this point B here, down to the center of its base. And that forms a right angle there. So we call it a right cone. There's such a thing as an oblique cone, right, where this vertex would be skewed, slanted off from the center of that base. All right, so now we have to ask, though, what's the base and how do we find that base area? Because again, remember the big B here is representing the area of the base. All right, and again, for a cone, the base is yet another circle, just like for the cylinder. So notice in this equation here, big B has been replaced with pi r squared because that's the area of a circle times the height. All right, so you notice that this formula is very similar to the one for a cylinder with one exception, that we end up dividing by 3 at the end. Remember, multiplying by a third and dividing by 3 are the same thing. All right, so let's go ahead and let's go ahead and figure out the volume of this particular cone. All right, so I'm going to use this formula out here. I'm going to say the volume then is equal to 1/3 times pi times the radius of that base, which is 3 in this case, squared times the height. So remember, the steps in doing this is exactly the same steps as finding the volume of a cylinder, except for at the very end, you just take that answer and divide it by 3. That's what that 1/3 in front means. All right, so I have to square first, following the order of operations. So 3 squared is 9. All right, and then now this becomes a calculator problem. All right, so I can simplify it a little bit if you want to on the right-hand side here. We can do 9 times 5, right? That's 45, and then 45 is basically being divided by 3. So if we wanted to, we could write this as 15 pi. Now, if you wanted just to go onto your calculator and just get the decimal equivalent right now, the way that I would do it is I would start right there. This last part, I would take pi times, 3.14 times 9 times 5. I'd get some number, and then I would divide by 3 at the end. That'd be it. If we want the exact value like this, then we simplify everything except for the pi, which I did here. So this would be what we'd call the exact volume, right, left in terms of pi. Then if I want the decimal equivalent, I can go ahead and multiply 15 times 3.14. And then we get that the approximate volume of this cone is 47.1 cubic units. All right, so take a moment and pause the video and see if you can find the volume of this cone. All right, so you should have started out with the formula. So for all these problems that are relating volume or height or even area, go back, dig in your notes, and pull out those formulas first. Because we know when we're being asked what's the volume that, well, maybe I have a formula for it. And of course we do here. So I start out by writing it down. 1/3 pi r squared h. Then I plug in what I know. All right, so in this case, we do know the radius, the r, and we do know the height. So these problems are actually very simple as long as you understand what the different letters mean. As long as you know what they mean by the base area, what the base of the figure is. As long as you know what the radius means when you're looking at a circle, or what the height means when we're looking at a particular figure. All right, so in this case, I'm going to go ahead and plug in those values. The radius, 6. 6 squared times the height times 7. Again, the most common mistake when calculating an answer for this, either a decimal or exact, is not to square the radius before you start multiplying by pi or the height. And so remember that the very first step I do here after I plug in those values for the r and the h is square that radius. So 6 squared is 36. All right, times 7. Now you could go ahead about simplifying this. So remember, if I wanted to leave this answer exact, I would do 36 times 7 and then divide it by 3 and then leave it in terms of pi. So let me go ahead and do that now. So literally, if you could watch me right now, right on my calculator, I'm typing 36 times 7. Then I hit equals, gives me 252, and then I say, okay, that's 252, and then I'm going to divide it by 3. All right, so divide that by 3, and I get 84. So when I calculated 1/3 times 36 times 7, I got 84. And then I just bring down the pi. So this would be an exact volume. Now if we want to get the approximate volume, right, we let pi be 3.14, and 84 times 3.14 is equal to 263.76. And as always, when we're doing volumes, that would be in cubic units. All right, so let's go about rearranging this formula now to solve for a particular measurement of interest. So here We have the problem that a cone now has a volume of 135 cubic units, and it has a radius of 9 units. What is the height? So we're being asked to solve for the height again. All right, so we start out with the formula like we always do. Write it down. Volume equals 1/3 times pi times the radius squared times the height. Start plugging in what your knowns are, what you know from the problem. Volume, 135. So I replace the V for the volume with 135. And I have 1/3 times pi. Remember, pi is not a variable. Radius, they tell me, is 9. Okay, so for the r, I'm going to plug in 9. That's all being squared. Times the height, which is our unknown. All right, so we're solving for the height here. So I'm going to start off by simplifying what's around it. This whole part right here that's being multiplied by the height, since none of those are variables, right? These are all numbers, even pi, right? That's a number. Since these are all numbers, I can go ahead and simplify that and get a single number. So then it's like some number times h equals 135, and then we just divide both sides by that number. So I think that's the simplest and most direct way to isolate the variable in this case. And so I'm going to go ahead and do that in my next step. And I have to square the 9 first, right? So remember, this does mean 1/3 times pi, and that's 9 times 9, not 9 times 2. And so 9 squared is 81 times the height. That equals 135. Okay, so I can still simplify here, right? Because we still have 1/3 times the pi times the 81. And so we might as well simplify that. So if I take 81 and divide it by 3, and that's all I'm going to do, I could get that, and that would be 27. So this is like 27 times pi times h. If you wanted, if the question was just asking you, right, for a decimal approximation of the height, then there's no problem right here going ahead and multiplying this 27 times 3.14. And so I'm going to go ahead and do that. Right now, the only time I wouldn't want to do that is if I looked at my answer choices, if this was multiple choice, and I saw answers that involved pi, then I would want to leave it exact. If I don't see that, then I'm going to go ahead and I'll go ahead and multiply. Just remember that it is best if you're going to approximate an answer to wait to round to the very last step of the problem to avoid making errors larger than they need to be, right, as you're doing calculations. All right, so now the last step would be divide both sides by 84.78, right, to isolate the h. We're doing the opposite of multiply, which is to divide. And this is the step I'm actually doing. I'm actually dividing both sides by 84.78. It's a 7. And I'm going to get an approximation for that height. And so in this case, the height is about equal to 135 divided by 84.78. And I get that the answer, the height in this case, is about equal to 1.59. So if I wanted to leave this answer exact, if they really wanted you to leave it exact in terms of pi, at this step, I would have divided both sides by 27 pi instead of getting this decimal approximation of 84.78. So I would have had that the height was equal to this. And then you could go ahead and simplify, like reduce this fraction, take out any common factors in the numerator and the denominator. And in this case, they do have a common factor of 3, so you could divide them both by 3. In fact, they share a common factor of 27. So 27 does go into 135 exactly 5 times. So when I did 135 divided by this, I was left with 5, and that would be in the numerator. Right? This would be like 5 over 1. So then when you get that the height was equal to 5 divided by pi. Right? So that would be the exact height of this cylinder. Excuse me, cone. All right, so then if you took 5 and divided it by pi and 3.14, you should end up with this answer here. All right, so the last figure we're going to look at, the last shape is a sphere, and that's your basic ball here, like you see here, three-dimensional ball, like the Earth is a sphere. Right, and the formula for a sphere only depends, or the volume, right, only depends on its radius. All right, so the radius of the sphere goes from the center of the sphere to the edge of the sphere. And the formula is simply 4/3 pi times the radius cubed. So notice it's not squared anymore. We're taking that radius and raising it to the third power. All right, so let's calculate the volume of this sphere. And it may be a little hard to see on your screen, but it's indicating that that radius is a 4. All right, so to calculate the volume, I'm going to say the volume is equal to 4/3 pi times the radius cubed. And then go ahead and plug in what we know. And all we need to know, right, to find the volume here is the radius, which is 4. So the volume is equal to 4/3 pi times 4 cubed. So remember, our first step here to simplify this and get a numerical answer is to cube that radius. That has to be my first step. So 4 to the third power is 64. All right, so then now if you really wanted to, you could go about simplifying 4/3 times 64 into a fraction and leave it in terms of pi. Or you could go ahead if the just wants a numerical answer, right? And multiply all these and then divide by 3. So if I were just looking for a decimal answer, the way that I would do it on my calculator right here is I would multiply 4 times 3.14 times 64. Then I'd hit my equal sign. It'd give me some number, and then I would divide that by 3. And so that's the easiest way to do that. Let's go ahead and leave it exact. Let's leave it in terms of pi. So if I take 64 and multiply it by 4, so all I'm doing is multiplying these two together, then divide it by 3, right, we get the number 85.33 or 85 and a third, so it doesn't quite simplify all the way. So it'd be about 85 and a third as a mixed number. So now if I wanted to go ahead and write that as an improper fraction, I could get that it was 255 over 3. Oh, 256, excuse me. Then now I'm going to go ahead and convert that into a decimal equivalent. All right, so in this example, I get about, after I convert it to a decimal, 2411.52 units cubed, or cubic units. So remember, this volume, what we are talking about is the space inside that, in this case, sphere. How much space is inside it? All right, so now take a look. Here's a different sphere. Go ahead and pause the video and see if you can calculate the volume of this sphere. All right, so the first thing you should have done is write down the formula. All right, so the volume is equal to 4/3 pi r cubed. Go ahead and write that out every time. I encourage you to do so. Then go ahead and start substituting in the numbers, our knowns. And remember, to find the volume of the sphere, all we need to know is the radius. We know it's 6. Volume equals 4/3 pi times the radius, which is 6 cubed. All right, now it just becomes working out and simplifying this answer using the order of operations. So these are really simple when you're given exactly what you need to know. Right? Just remember to cube, do exponents before you do any multiplying or dividing. So I do have to take 6 and raise it to the third power first, which is 216. And then now we can go about simplifying this answer. Okay, so 26. So if I were doing this and if I just wanted the decimal equivalent right now, I would literally go on my calculator and do 4 times 3.14 times 216, hit the equal sign, and then hit divide by 3. I'm going to do that this time just to see what we get. So I'm going to write 4 times 3.14 times 216, hit my equal sign, and I get a number, and then I have to divide that by 3. That's the last step. All right, and when I do that, I get about 904.32. Remember, I'm saying that's about the volume of the sphere because we approximated pi, right, as 3.14. If I wanted to leave it exact, then it's about simplifying these numbers out here. So I might do 4 times 216 and then see if that number is divisible by 3. And it is. All right, so I did 4 times 216. I divided by 3, and I actually got 288 exactly. So 288, and the pi is still there. So the exact volume is 288 pi cubic units, which is about equal to 904.32 cubic units. All right, so just like before, when we were doing with the volume of the cylinder and the cone, we could have been given the volume and then asked to find either the height or the radius. In this case, remember the volume of a sphere only depends on the radius, so it could be the case that you're told what the volume of the sphere is and then asked to find the radius. And so then we're going to have to use inverse operations to get that radius by itself. So let's go ahead and do that. Start with the formula. Write it out. Volume equals 4/3 pi r cubed. Let's plug in what we know. In this case, it's the volume. Right, so 105 is equal to 4/3 pi times the radius cubed. All right, so what our goal is here is to isolate that r, right? Isolate our variable r here. So I'm trying to get this r cubed term here by itself, that piece. All right, that means I want to get rid of the 4/3 pi here that's being multiplied by it in front. All right, remember, think of this as just one large number. This problem here is no different than if you had a problem that said 105 is equal to 3x cubed. Right, to start to solve for the x here, right, I would first divide both sides by 3 by that coefficient because we have to undo PEMDAS, right? We have to do the opposite thing in the opposite order. So the first step here would be to divide by 3. Well, my first step here is going to be to get rid of this. All right, so there's two things you could do. Again, if you're just looking for a decimal approximation of that radius, then you could go ahead and calculate out what that number is, meaning go on your calculator and do 4 times 3.14 divided by 3 and see what you get. All right, so when I do that, in this case, I get a number that's about 4.187. 7 times the radius cubed is equal to 105. Next step, just like in this step here, I would divide both sides by 3. If I were solving this problem, remember these are two separate problems here. Don't get them confused. I'm going to divide both sides by 3. Well, in this case, I'm going to divide both sides by our 4.187. All right, so 105 divided by 4.187 is about equal to 25.08 is equal to the radius cubed. And then now we don't want to know what the radius cubed is. Remember this here, meaning r to the third power, does mean r times r times r. So we don't want to know what r cubed is. We just want to know the r. So the most common error here is how do I undo raising something to the third power? And most of the time I get answers like divide both sides by 3, right? But that would be this. If it said 3r is equal to 25.08, then I would be dividing both sides by 3, right? Because I'd be undoing multiplication by using the inverse division. In this case, we need to know what the inverse of cubing something is, raising to the third power. And that, of course, is taking the cubed root. So in general, right, when to undo raising to a power, you're going to take the root of that power. So in this case, it's a cubed. We're cubing something, so we're going to take the cubed root. If we were squaring something, right, we would take the square root. If we had something raised to the fourth power, we'd be taking the fourth root. All right, so that does mean when I'm taking the cubed root of both sides, it does mean I'm looking for a number that when I'm times it by its own self is equal to what's underneath the radical here. This is what undoes itself on the right-hand side, so we just end up with r. And then now I'm going to go ahead and take the cubed root of 25.8. Now, on most calculators, most scientific calculators, they already have a cubed root button. You'll see it looks like this. So I would type 25.08 and then hit that button on my calculator. Otherwise, there should be another button that might look like this. This might be an X or a Y up here, but that means take the root of, any index that I want. So if I needed to take the fourth root of something, I would plug in that number, hit this button, and then hit 4, for example. All right, so here I'm going to go ahead and take the cubed root of 25.08. I'm going to go to my calculator, and I have a cubed root button already on there, so I just go ahead and click it, and it tells me that it is about 2.93. 2.93 units, whatever the units were for that radius, or that and the volume here. Remember, you could also leave this more exact here, and did it at the end by simplifying, dividing both sides by 4/3 pi, and then rounding after you took the cubed root. All right, so that concludes today's lessons. If you're watching this asynchronously, make sure to go back to the course announcements and answer the asynchronous questions.